This is a harder example of the method of solving simultaneous equations by substitution. This is our system of equations. I'm going to call the first equation equation number 1. And the second equation, equation number 2. If I take the first equation, I can rearrange it so that I get x in terms of y. 2x is equal to 4 minus 7y, and dividing by 2 will give me x is equal to 4 minus 7y divided by 2. I can now take this expression for x and substitute it into this part of equation number 2. So I substitute x equals 4 minus 7y divided by 2 into equation number 2. Important at each stage to write down exactly what you're doing. So my equation number 2 becomes 2y minus 3 brackets 4 minus 7y divided by 2, because that is what I have for x, equals 19. And if you look at this equation now, it's an equation that's only got y in it. It doesn't have any x in it, so we can solve it fairly simply. The most clumsy thing about it is the 2 in the denominator. So our next step is to multiply each term by 2. 2y multiplied by 2 gives me 4y. The middle term becomes that because I'm multiplying by 2, which is cancelling out with the 2 on the denominator. And I must multiply my 19 by 2 and get 38. The next step will be to remove the brackets from the middle term. So now we have 4y minus 3 multiplied by 4 is 12, and negative 3 multiplied by negative 7y gives me positive 21. Why? You need to be careful there because there are two negatives being multiplied together. And I have equals 38. I'm going to group the y's together, which gives me 25y. Move the 12 over to the other side, and I have 38 plus 12 is 50. And to get the value for y, I divide 50 by the coefficient of y. 50 divided by 25 is 2. So this is my value for y. To find the corresponding value for x, I'm going to substitute. I'm going to put y equals 2 into one of the initial equations. So we'll put it into equation number 1. We have 2x plus 7 multiplied by 2, because that is our value for y, equals 4. 2x plus 14 equals 4. And in order to get the value for 2x for the next line, I must subtract 14 from both sides. 4 minus 14 giving me negative 10. And so the value for x that satisfies both equations is negative 10 divided by 2, which is negative 5. And as always, we should do a check. And I'm going to check with equation number 2, because that's the equation we didn't use at this part of the solution. 2y, which is 2 multiplied by 2, minus 3 multiplied by negative 5 equals 19. Is that true? 2 multiplied by 2 is 4. Negative 3 multiplied by negative 5 gives me plus 15, which equals 19. So our solution of x equals -5 and y equals 2 is correct.